Welcome back, students, to Chapter 3, Circle, Practice Set 3.4. Now, the sixth sum in Practice Set 3.4, they have given the figure, okay, and you can see there is a triangle WXY, okay. The altitudes you can see here YZ and XT. These are the altitudes in this triangle. They intersect each other at point P. And we have to prove that quadrilateral WZPT. You can see this four sides, a quadrilateral is formed at the top. It's cyclic. And we have to prove that point X, Z, T, Y are concyclic. Okay. Now, if you look at the figure, you will see that since we have altitude YZ on XW and altitude XT on WY, we have a 90-degree angle at these points. Okay. Therefore, we can say that angle YZW, that is this angle which I am marking, and angle WTX. So this angle, okay, these two angles are 90-degree each. Therefore, angle WZP, okay, WZP and WZY are one and the same angle. So WZP plus angle WTP, 90 plus 90 is 180. Therefore, the sum of these two opposite angles of this quadrilateral, okay, are supplementary. And if the sum of the opposite angles of a quadrilateral are supplementary, then the quadrilateral is cyclic. We have studied in the converse of cyclic quadrilateral. Okay. So, we are going to use the property of the theorem of converse of cyclic quadrilateral. So, here same thing. We have written which angles are 90 degree, WZP in this quadrilateral, WZPT. Okay, so you can mention here in quadrilateral, okay, WZPT. Okay, we are talking about this quadrilateral. We are in the quadrilateral, these opposite two angles are 90 degree each. Therefore, if we take the sum of those two angles, we get 90 plus 90, 180. Okay, and by the converse of cyclic quadrilateral theorem, we say that this quadrilateral is a cyclic quadrilateral. Now, we have to prove that these points, that is point X, Z, T and Y, X, Z, T and Y are concyclic. Now, in the textbook on page number 70, we have studied the property, that is the points X and Y, you can see points X and Y, they are on this line, okay, and they make the angle of 90 degree on the same side, that is X, Z, Y, angle X, Z, Y and angle X, T, Y, they make or they subtend a 90 degree or a right angle on the same side of the line, and in that case, point X, Z, T and Y, they are concyclic points, and this property we have seen on page number 70. So, since the condition is fulfilled that there is a line, then that line makes two angles at two different points, two distinct points, and make an angle of 90 degree, then the 4 points which are there, all those 4 points are concyclic. So, we just have to say that these two angles are 90 degree, that is angle XZY and angle XTY are 90 degree given. And then you will write the full statement which is on page number 70. Points X and Y on line XY subtends equal angles at two distinct points Z and T on the same side of the line XY. Then the 4 points are concyclic. Therefore, point X, Z, T and Y are concyclic. Clear? Now, sum number 7. They have given the figure. There is a circle, okay, and you can see that these two lines they meet each other outside in the exterior of the circle at point M. Okay, so chord EN and chord FS of the lines, they intersect each other at point M. Okay, it is shown in the figure. Arc NS, which you can see, is 125 degree. Arc EF is 37 degree. And we have to measure NMS. Okay. So now we have studied the property on page number 72. Okay, there is a proof which we have to write on page number 72. They have given that if the two lines containing chords of a circle which intersect each other outside the circle. Now if you see in the figure, chord EN and chord FS. Okay. So they are a part of this lines which I am showing you. And they intersect each other in the exterior of the circle. Clear? Outside the circle. Then the measure of the angle between them. What is the angle between these two chords? This angle NMS is half the difference of the measure of the arcs intercepted by angle. Now this angle intercept two arcs NS and EF. So according to the statement, angle NMS is half of measure arc NS minus measure arc EF. Okay. So we will first write what is given, that is measure arc NS is 125 degrees and measure arc EF is 37 degrees. Then we'll write the statement. Okay. The statement pertaining to the figure, that is you can see the figure here, that is NMS has its vertex in the exterior of the circle and intercepts arc NS and EF. Therefore, according to the theorem, angle NMS is equal to half measure arc NS minus EF. So measure arc NS, you can see where is measure arc NS here, minus EF. I told you the bigger arc minus smaller arc. Okay. So now from this we know both the measure of both the arcs. So 125 minus 37 we have substituted. Then 125 minus 37 is 88. 88 upon 2 is 44 degrees. So we got the measure of angle NMS as 44 degrees. And now the eighth sum, they have given the figure where you see that the chords AC and chord DE, they intersect inside the circle at point B. Okay, and angle ABE is given 108, this angle. AE measure arc 95 and we have to find DC. So just before this we have solved the seventh sum where it is shown that these chords, they intersect each other. Okay, they are part of the line and they intersect outside the circle. And therefore the property was used where there was a difference. Now same, but only thing is we have to take the addition of the arcs. Okay, so we have studied this property on page number 71 here. If two chords of a circle intersect each other in the interior of a circle, then the measure of the angle between them is half the sum of the measures of arcs intercepted by the angle and its opposite angle. Okay. Now it is given that measure arc AE. You can see here measure arc A is 95 degree and angle ABE is given as 108 degrees. Okay. And as I read the property on page number 71, angle ABE has the vertex inside the circle and it intercepts arc AE and DC. Okay. And its vertically opposite angle DBC intercepts DC. Okay. That you have to mention. Clear? In such case, when the chords intersect each other internally, okay, then the angle is equal to half of the sum of the intercepted arcs. I said we have to add in this case. When the chords intersect inside the circle, we have to add the arcs. And when the chords intersect outside, then we have to subtract the arcs. So here angle ABE is equal to half of arc measure arc AE plus DC. Out of this angle AB is given. Okay. We'll make the correction, angle ABE here. Angle AB is given 108 degrees is equal to half of measure arc A is 95 plus DC. So if we know all the measures here and DC, we can find. So 108, 2 goes to the other side. Okay, 95 degree plus measure of arc DC remains on other side, and therefore 108 into 2 is 216 equal to 95 degree plus measure of arc DC. 95 goes to the other side, it subtracts, and we get the answer 121 degrees. So measure of arc DC is equal to final answer 121 degrees. Homework. Complete the sums solved in this video in your notebook. Thank you.